Welcome. Let's take a look at an example of finding absolute extrema for a function on an interval. As a reminder, when f is a continuous function over a closed bounded interval I, the absolute maximum of f over that interval and the absolute minimum of f over that interval must occur either at the endpoints of the interval or at the critical points of the function that lie in the interval. So let's go ahead and take a look at this problem. Find the absolute extrema for f of x equals 3x minus 4 times sine of x on the interval from 0 to 2 pi. So keeping in mind that in our search for absolute maximum and absolute minimums, we have to consider the endpoints of the interval and the critical points of the function that lie within that interval. So let's go ahead and find the critical points of the function that lie within this interval. So to find the critical points of the function, we need to investigate two scenarios. The first is where does the derivative of the function equal 0? And the second is where is the derivative undefined? So let's go ahead and find the derivative of our function. F prime of x is equal to, now the derivative of 3x is 3, minus 4 times the derivative of sine of x, and the derivative of sine of x is cosine of x. Now, as we look at this function, this derivative, we have 3 minus 4 times cosine x. And this function is defined for all real numbers. So in my search for critical numbers, I do not have to consider the second scenario where my derivative is undefined, because my derivative is defined for all real numbers. So let's focus on the first criteria, that is f prime of x is equal to 0. So we want to solve this equation, 3 minus 4 times cosine of x equals 0. Well, if I add or subtract 3 from both sides of my equation, I get negative 4 cosine of x equals negative 3. And then if I divide both sides of this equation by negative 4, I end up with cosine of x equals 3/4. Now, cosine of x equals 3/4, you're not going to find that on the unit circle. This ratio of 3/4 is not any of the standard unit circle values that we learn in trigonometry. However, the angle does exist that creates a cosine of 3/4, and we can communicate that by saying x is equal to the inverse cosine of 3/4. And just so you have a notion of how big that is, that's about 0.723 radians. And keep in mind that pi over 2 is approximately 1.6 or 1.57 radians. So this angle, inverse cosine of 3/4, is smaller than pi over 2, which means it lands within the first quadrant if you're thinking about the unit circle. So if we were looking at the coordinate plane, we'd have something looking like this. Our angle of arc cosine or inverse cosine of 3/4 is a little less than half of pi over 2. And recall that the angle of pi over 2 takes you to the positive y-axis. So our inverse cosine is here. And keep in mind that we're looking for all values x in the interval 0 to 2 pi. Now keep in mind that there is a second angle whose cosine is 3/4, and that second angle would occur here in the fourth quadrant, and it would be the angle that's measured from the positive x-axis around the origin to that ray. And that angle is 2 pi, is a 1 full rotation. So this angle here is 2 pi minus inverse cosine or arc cosine of 3/4, which is approximately 5.56 radians. So what we have here are two critical numbers. We have x equals the inverse cosine of 3/4 simply from solving the equation, but we do have to rely on our knowledge of trigonometry and realize that there is this second angle that lies in the fourth quadrant because we are interested from 0 to 2 pi of x equals 2 pi minus cosine inverse of 3/4. Now, coming back to our goal here to find the absolute extrema, recall that we must consider the endpoints and the critical points on the interval. Now, both of these angles, inverse cosine of 3/4 and 2 pi minus cosine inverse of 3/4, lie within this interval from 0 to 2 pi. So we're going to be evaluating our function at f at 0, my endpoint, f at my first critical point, which is cosine inverse of 3/4, f at my second critical point, f at 2 pi minus cosine inverse of 3/4, and then finally f at my other endpoint, which is 2 pi. So f of 0 will be 3 times 0 minus 4 times the sine of 0, which ends up being 0. F of arc cosine of 3/4 is a little more complicated. It would be 3 times cosine inverse of 3/4 minus 4 times the sine of cosine inverse of 3/4. So what we'll do is we'll go ahead and approximate this to 4 decimal places. So that's approximately negative 0.4775. We have a similar issue with f of 2 pi minus cosine inverse. We'll have 3 times 2 pi minus cosine inverse of 3/4 minus 4 times sine of cosine inverse of 3/4. Not as simply done analytically. It can be done. We'll go ahead and approximate this to 4 decimal places. We'll have 19.3271. And then finally our f at 2 pi would be 3 times 2 pi minus 4 times sine of 2 pi. And that's equal to 6 pi. Now, as we go about identifying which of these might be our absolute maximum, we need to be a little careful. We have one output value of 19.3271 and another one of 6 pi. And in this form, it's difficult to tell which is largest. So let's go ahead and approximate 6 pi. 6 pi to 4 decimal places is approximately 18.8496. So in this form, we can identify that our maximum value occurs at 2 pi minus arc cosine of 3/4. Looking for our absolute minimum, we see that we do have one negative value one that's 0 and 2 that are positive. So this output value of approximately negative 0.4775 would be our absolute minimum. So we can say that the absolute max, and now we did approximate because of the form of the function, so we'll say is approximately what did we say? 19.3271, and it happens at x equals 2 pi minus arc cosine of 3/4. Let me get rid of that. There we go. Okay, and then we can say that our absolute minimum is approximately what did we say? Negative 0.4775, and that occurs at x equals arc cosine or inverse cosine of 3/4. I hope you find this helpful.